Example 20 looks at finding the exact value of the following definite integrals. Part A for this is the integral between 0 and pi on 4 of sine of 2x. So our first step is just to do that integration. So sine 2x becomes negative 1/2 cos 2x. We're still going between pi on 4 and 0. Next step, we've got to substitute in those pi on 4s and those zeros. So we're going to have negative 1/2 cos of pi on 2, or 2 times pi on 4, we'll simplify it in a moment, minus negative 1/2 cos 2 times 0. Simplifying this, we'll get negative 1/2 cos pi on 2 minus negative 1/2 cos of 0. Thinking back to our unit circles, cos of pi on 2 is 0 and cos of 0 is 1. So this is 0 minus negative 1/2 times 1, which gives us 1/2. Now in example B, we have the function 2 cos x plus 1 dx, integrating between 0 and pi on 2. So first step, we need to do our integration. So 2 cos x becomes 2 sine x, and then plus 1 becomes plus x. Putting in our limits, pi on 2 and 0. Substitute in pi on 2, so 2 sine pi on 2 plus pi on 2. And then also substituting in 0, so 2 sine 0 plus 0. So sine of pi on 2 is 1, sorry. And sine of 0 is 0. When we simplify that, we end up with 2 plus pi on 2. So these two examples demonstrate doing an integration involving a trigonometry, or a trig function, and then using that to solve the definite integrals provided.